All right. So I am David Duber. This is a very gentle introduction to Mplus that doesn't assume too much prior knowledge. And Mplus is a powerful statistical program that's specifically designed for latent variable modeling. So if there's some construct that we want to know about, but there's no direct way to measure it, and we have to use an instrument with a battery of items, Mplus is very good at doing modeling to learn about that underlying latent variable. It's particularly notable for handling both continuous and ordinal data, and they have new versions roughly every year. They started out in 1998 with version 1. They're on version 7.4, and each version has included a significant number of new features, so it's being actively developed. Mplus uses syntax-based input files and text-based data files. So unlike if you're more familiar with, say, SPSS, where everything is driven by selecting things from menus and clicking on these checkboxes and dragging things around, Mplus isn't like that. It uses a syntax that's very general and fairly easy to learn. So the developers are the Mutanes from the University of California, or UCLA. So latent variable modeling, again, is where you have observed variables that are not really your object of interest. Your object of interest is an underlying latent construct, and latent variable modeling is about learning about that underlying construct. An easy example is self-efficacy, which is popular right now in psychological measurement literature. And there's no easy, direct way to measure it. There's no such thing as a self-efficacy ruler, where I can get out my self-efficacy ruler and walk up to you and say, you have 3.7 self-efficacies. It doesn't make sense, it's not possible. But what we can do is we can come up with a bunch of items that are intended to measure self-efficacy, and then based on observed responses to those items, can model the latent construct self-efficacy. And so that's the kind of thing that Mplus does. Some of the major advantages of Mplus is it's very versatile. Mplus handles a wide variety of latent variable models. And what's really cool about Mplus is that it can combine those different models in a fairly seamless way without having to learn a new tool. It's the same syntax language for everything. So its syntax language is very simple. Most of the very powerful, very generic statistical programs are syntax-based. You'll hear about R and SAS and Mplus a lot. They're all syntax-based, and Mplus, one of the major advantages of Mplus is that its syntax is easier to pick up. It doesn't require any prior programming experience. You don't need to learn to be a programmer and to learn the syntax and to learn all the statistical analyses at the same time. So some capabilities of Mplus. It has a whole lot of them. There's a great big long list that I could have made even longer and longer and longer. And like I said, one of the great advantages of Mplus is that you can kind of combine any of these capabilities in any way that you want. You can do Bayesian analysis to compute multi-level models of longitudinal data as one of the levels. So just a quick comparison of some common statistical software that you've probably used or at least heard of before. And one notable thing about this table is that maybe 6 or 7 years ago there would have been a lot of no's on this table. But in recent years, some of the more popular statistical software have gotten a lot more powerful, have gotten a lot better. And R, for example, has kind of the core R engine can do a lot of stuff, but one of the reasons people like R is it has all these packages. There's an R package, Levon is a popular one for doing partial equation modeling. There's another R package for doing mixture modeling. And it can do all those things. But in R, a lot of times you have to go find a package that will do what you want, and you have to learn its own syntax. And then if you wanted to do both of those things together, maybe you would need yet another package for that. SAS is similar insofar as SAS uses different procedures for different types of analyses, and they're all inside of the SAS language. But Mplus is nice because all of these different features use the same general syntax language So you don't have to go find new scripts, find new packages, learn new syntaxes. It's all one common syntax language for all the things that it can do. And that is a major reason that we like Mplus so much. So I've mentioned this first point, its ability to combine its capabilities seamlessly. One nice thing about Mplus is that since its modeling is so general, so generic, sometimes new analyses are either very easy to implement in Mplus, or they can just be done in Mplus straight away. In 2010, some people came up with Thurstonian IRT, which is a way of analyzing forced choice data, where if I give you an item, instead of saying how highly do you rate this item, maybe compare it to another item. Which item do you like more? That kind of data. And it was able to be implemented in Mplus without any modification to Mplus. And at that time, originally, there was no other program that could handle it. There is now an R. There is a package for R that will handle Thurstonian IRT. But the point is, there was this cool new analytical technique that could just be done in Mplus. There was no need for the Mplus developers to accommodate for this new technique. That's not going to happen for every new technique, obviously. But the point is that the modeling inside of Mplus is very generic. If you've done mediation analysis with lots of different possible pathways, it can be very annoying to do one pathway and then another pathway and then another pathway. And Mplus has a nifty way to test many of them and to do moderated mediation analyses and all that kind of stuff is very easy to do in Mplus compared to other programs. We might have a talk later in the year that discusses that. Okay, so there's always a catch, right? Nothing is perfect. There's always a catch. So the cost of Mplus is pretty high. The student version is $350. The commercial version with all of the mixture add-on and whatnot is well over $1,000. We do have 3 computers in this building in the lab in Taylor Ed 151 that have Mplus installed. And there may be grants available for you. If you absolutely need it for your dissertation, you may be able to ask the grad school for some money. Sort of the elephant in the room is that I've been saying great things about this syntax language, but there's still a syntax language that you have to learn. It is a relatively simple language to learn. It is fairly generic, so once you've learned it, you've learned it. But there's a hurdle to overcome at the very beginning of learning that language. Mplus also lacks some of the bells and whistles of more specialized programs. There are specialized programs for IRT, for example, FlexMert, that will compute these things called M2 limited information goodness of fit statistics that Mplus isn't going to be able to compute for you. Some of those little bells and whistles are easily calculatable from data that Mplus produces, and you can do them in Excel and figure out this index or that statistic or whatever. And not always, though. The M2 limited information goodness of fit statistics, if you need that, well, you have to use FlexMert. But to the last point, no program can do everything. And so Mplus doesn't have some bells and whistles, but it has a whole lot of features. So the combination of analyses that can produce is very impressive. I don't think you can point to another program and say, oh, this program can clearly do a lot more stuff than Mplus. There is no program like that. The syntax language it uses is simple and generic. And to reiterate a point from the very beginning, Mplus can natively handle both ordinal and continuous variables. So if you have binary data or you have Likert type data that you feel is inappropriate to treat it as continuous, Mplus is going to be able to handle it correctly without a big fuss. I'll do an example like that. So any questions before I move on to my examples? That's fine. The first example I wanted to give just a simple example of regression, so you can see kind of how some pieces of Mplus works. NASCAR, the National Association of Stock Car Auto Racing, has 21 different tracks that they have their races on, and they're not all the same size and shape. The races you're most familiar with, the Brickyard 400, the Indy 500, those tracks are almost identical to each other, but the 21 tracks are very different. They have different lengths. The shortest track is just over half a mile. The longest is 2.5 miles. The curves are banked so that you can go faster along. And there's other things like this, the type of surface and whatnot that make a difference. So Ricky Bobby wants to go fast. And the question is, can we predict how fast you can go on the track? In this case, measured by the record lap speed, the fastest speed anyone has ever traveled for a lap, average speed for the lap. Can we predict that based on the length of the track and the banking of the curves, the maximum banking of the curves, so that Ricky Bobby can figure out what tracks he's going to be able to go fastest on? And so our path diagram, we've got two independent variables, the track length and the maximum degrees of banking on the track. And we're using them to predict another observed variable, the top speed. And of course, in this regression model, we're not going to be able to completely predict top speed, so there is also a residual there. So when I had mentioned earlier that Mplus uses as its data files text files. They can be comma separated data, that you can separate them with a space, with a tab, any of the same things that you would use for a CSV file. So in SPSS, SPSS is fantastic for data management. And so a lot of times you'll pull your data into SPSS, do some data management things, figure out what you need to clean up. And you'll want to export it so you can use it in Mplus. And you can just save the data as, use the save as feature as a .csv file. And the one thing you want to make absolutely sure about is to uncheck the right variable names to spreadsheet checkbox. The input for Mplus has to only be numbers. And if it has any kind of letters in it, it says, I can't handle letters, I deal with numbers. So, so you don't want the variable names in the spreadsheet. Mplus wouldn't like that. If you have your data in Excel, you do the same thing. You save it as a .csv file. It doesn't have to be .csv. You can use .text, .data, whatever you want, so long as it's comma, tab, or space separated. So here's the data file for the 21 tracks and the various parameters. Now this is the file that we're going to have Mplus read, and an important thing about it is that the columns, the variables, don't have names. So what they are, the first column is the track length measured in miles. The second column is the maximum banking around the curves, measured in degrees. Third column, the record top speed. And the fourth column is the year in which the record was set. So when we tell Mplus to open this, we're going to have to tell it what those variables are. So here's my input file for this regression example, where I'm going to figure out how well I can predict that record top speed. These different components, title, data, variable, model, plot, and output, are common to Mplus input files. There's a few more possible different kind of blocks inside of the Mplus input file, but these are the most common ones. So the title can be anything. You can name it whatever you want, and the only difference the title makes is it's going to put that title on the top of its output. The data, you need to tell it where the data is, and if it's in the same folder as your input file, you just give it the name. Otherwise, you have to give the full path of the file. Now in the variables, we have to tell, since the variable names aren't part of the CSV file that we're telling Mplus to use, we have to tell it what those variables are. So each column, the first column was the track length, so I'm calling that length. The second column was the banking, top speed, and year. Now importantly, a variable in Mplus can have a maximum of 8 characters. If you use 9 characters, it won't like it. It'll give you an error, and you'll have to go make it 8 characters or fewer. Now that year variable, the year in which the record was set, that's irrelevant to what I want to do. And so use variables, the next part of the variable statement, tells Mplus which variables I'm going to use in my model. I'm going to create a regression model for top speed using banking and length as the independent variables. The year doesn't come into it. So I need to tell Mplus which variables get to be in the model. And so they are length, banking, and top speed. Okay. And you can deal with missing data inside of Mplus. We don't have any, so I won't really talk about it. The model command tells Mplus what I want it to measure, how I want it to do the measurement to create the model. Regression uses the on statement. So on the left side of the on statement is the dependent variable, and on the right side I just list all the independent variables. And that's it. I've just told Mplus how to do the regression example from that, to do the regression model from that path analysis diagram. Mplus can generate some plots. I'm not really going to go over the types of plots and what they're for, but plot 1 is for scatter plots of data, one variable against another. In this case, it'll give me top speed as the y-coordinate and banking as the x-coordinate, a separate graph with length as the x-coordinate and top speed as the y-coordinate, things like that. Now it would be a good time to mention that other than the title command, every line ends in a semicolon, and you will write Mplus input files, and it will give you a nasty error, and you will say, oh my goodness, my model command didn't have a semicolon at the end. But you'll get over it, and you'll get your analysis eventually. As far as the output are concerned, SAMStat is short for sample statistics. It'll give me the means, the variances, the correlation between my variables. Standardized is, it's going to standardize the variables and then redo the analysis for me. And C intervals is for confidence intervals. I have a habit of attaching these three things to the output on every single input file I ever have. They don't always make sense for every analysis, but I'd rather include it and then have Mplus say, I can't do that for you, than forget them. Okay, so the SAMStats, it gives me sample statistics. It gives me means, covariances, and correlations. Now importantly, the formulas for covariances and correlations in Mplus are population formulas, not sample formulas. Generally speaking, we do latent variable modeling with a lot of participants, with a lot of data. And so if you have 10, 15 items in your sample, these are going to be biased, and you'll need to correct them. But generally speaking, you wouldn't do any of those really complicated analyses that I mentioned before, that multi-level modeling and structural equation modeling with 10 people in your sample. You would have a lot. And if you even have 30, the error is 1%. If you even have 100, the error is minuscule. You don't need to worry about it at all. So it uses population formulas. If you have very small sample sizes, you'll want to correct that. But generally, it's not an issue. So in the output of the model results, the model block of the input file was where it told us, where we told it what regression we want to do. So in the model results, it tells us the result of that regression analysis. Now you do have to kind of know what it's telling you, right? It just says estimate. It doesn't tell you that is the, in SPSS, it would be the capital B value. It's the regression weight for banking, or for top speed on banking. So the coefficient for banking. And what Mplus does for almost everything it estimates for you is after it gives you the estimate, it computes, if it can, a standard error for that estimate, and then performs a z-test for that parameter's significance. So if you have the length, for example, has a regression weight of 33.985, and it computed the standard error was 6.37. So if you divide those, you get a z-score, and then you can look that up in a standard normal table to find a p-value. So you can see that the banking variable is not a statistically significant predictor of top speed with a p-value of over 0.1, but the length is. Okay? And it does that for the intercept. The z-test there would be, is the intercept significantly different from 0? It also computes the residual variance for you. So if you knew, for example, the variance of the covariance of top speed with itself, the variance was 826. The residual variance is 319.5. That tells you the percentage of variance explained, and that's what it gives you down there. A little bit lower in the output, it gives you the things for r squared. Now, normally we don't compute r squared with a z-test based on computing r squared finding out a standard error, dividing and doing looking it up in a standard normal table. And normally we do an f-test. But if you have the r-squared value and you know your degrees of freedom, you can just compute the f-test manually if you feel like you really need the f-test. If you give it to your professor or reviewer and they say, I don't like this z-test for regression, I've never seen that before, I want you to give me an f-test, you don't have to go pull up another program or something. You can just compute this by hand in 10 seconds. Marie?
How?
Okay, how? Like this. So there's the formula for f is this formula. It has the r-squared in it, the number of cases, and the number of parameters that you estimate to compare the full regression model with two intercepts and with two regression weights, two slopes, whatever you want to call them, and an intercept, to the baseline model with just the intercept. So there's two extra parameters being estimated. That's why k is 2. And this is just, it's a formula. If you've taken a stats class, if you've taken a regression class, you've seen this formula in your book. It might have escaped from your head since then, but it's certainly something you can look up. And the degrees of freedom are the number of parameters to be estimated and minus k minus 1. And you can, I don't know if you can do it with f-tests, but I know with z-tests, you can literally Google z equals this, what is p, and it'll just tell you the answer. I don't know if you can do that with f-tests, but it'll perform it. And the difference in p-value between this f-test and the previous z-test for the significance of r-squared, they're going to be very small, especially as sample size increases. So for very, very small sample size, there might be a difference between them. I'm not sure. But if you have hundreds and hundreds of people, they're going to be exactly the same. Okay, so it gave us the regular output, the b values in the regression equation, and the intercept, told us all that stuff, gave us statistical significance. Sometimes in regression, we want to be able to compare the effect of the two predictors. And the standardized results let us do that. These are, in SPSS world, these would be the beta weights. These are the beta values. And so the length, not surprisingly, has a much greater effect on a standardized metric than the banking does. And all the p-values will be exactly the same as they were for the original table. So I mentioned it, that Mplus produces plots, and as with every statistical program that produces plots for you, they're not plots that you're going to put in your paper. Okay? Regardless of what program you use, you're going to have to make those plots yourself in Excel to make them really nice looking. And so this scatter plot here, one of the options in the menu is to save the plot data. And it'll save it, I think, as a CSV file. You can open it up in Excel and just make your plot right over again. So the taking the graph and replicating it in Excel takes almost no time at all. You don't have to go digging for that data and copy and paste or anything. It's literally save the plot data. I enjoyed that. Okay, so we had a regression example. What does our APA style write-up look like? The multiple regression model with track length and banking steepness was statistically significant at explaining variability in top speed with an r-squared value of 0.61, z of 4.64, and p less than 0.01 or 0.001. The track length had a statistically significant positive regression weight, but the regression weight for banking steepness was not statistically significant. So all that stuff you put in a standard APA style write-up for regression is just right there in the tables. All right, questions? Yeah.
In terms of your initial premise, why isn't the correlation between bank and length higher than it is? There's only a 0.1. Seems to me if I was a track constructor, the shorter the track, greater the bank, right?
Right. There's strong mediation happening there. There's also, not all those tracks are the same shape. There are some tracks that are shaped like that.
Oh.
And this banking statistic is the maximum bank. And so there's at least one track that famously has a really steep curve, but the other 4 curves are really shallow. And so if the banking were the same on every turn, like they are in the Indianapolis track, you would, I believe, you would have a much stronger correlation there. Anyone else? All right. So a second example, a correlation example. We like to use instruments using Likert type response formats, however many options. Let's say we're using items with 4 options, and we've got these 2 items that we think they might be very similar to each other, and we don't know if it's really appropriate to use both of them, and that's one of the questions in our current study. Well, one way that we could consider their relationship is by looking at their correlation. If two items are correlated at some ridiculously high level, say 0.95, I would feel pretty comfortable saying, well, these are basically the same item, and including both of them is a waste of my time. I'm only going to use one. I don't have in my head a specific cut point, but I certainly know correlation is going to be part of the answer. And this is a made-up example, so I didn't take this from anything. So our research question is, what's the correlation between the scores of these 2 items? Very simple. And in our Mplus input file, the only thing that's changed are, well, the names of my variables are different. My file is a different file. I gave it a different title, and all of those changes are very straightforward. You know, I can take the title data and variable blocks from one analysis, put them straight into another, and just make the necessary changes. And it's really not a big deal. So those 3 blocks, I don't ever really have to worry about them. I'm just going to copy and paste and edit. My model is different. With regression, I regress the dependent variable on the independent variables. If you want Mplus to think about correlation instead of regression, you use with. If you wanted Mplus to do a latent variable measurement model, like a CFA kind of thing, you would use by. Latent variables measured by, and then the observed variables. And those are the 3 main commands in the model, in the model block. On for regression, with for correlation, and by for measured by, in the CFA kind of sense. And it's worth kind of stopping and thinking about that for a second. Mplus is this hugely powerful program that can do a wide variety of analyses. But as far as the model is concerned, there's a grand total of 3 different operators that you need to know how they work in order to properly specify your model. Now, granted, if you have multi-level data and censoring and all kinds of crazy things like that, you will need to learn how to deal with those things in syntax. But as far as defining your SEM model, by, with, and on, 3 things, and that's it. I cannot get over how cool it is. Anyway, we tell item 1 with item 2 is going to tell us, for observed variables, it's going to tell us what their correlation is. And I'm not asking for the sample statistics, the standardized output, and the confidence intervals, because I always do. Okay. So when it gives me the model results, item 1 with item 2, I think, fantastic. If my correlation is 0.315. No, that's not what the correlation is. I actually misspoke earlier when I said that the with was for correlation. With is for covariance, not for correlation. So the covariance between item 1 and item 2 is 0.315. Okay. The standardized model results, standardized covariance is correlation. So I find my correlations down here in the standardized results. For what it's worth, that correlation is also in a table called correlations in the sample statistics. But with tells you covariances, and the standardized model will give you the correlations. So my correlation was 0.657. So I wrote up a little something about how the correlation between these 2 items is 0.657, and I feel okay with that. They're similar to each other, but not that same item. I'm going to keep them. I'm happy. And so a psychometrician was reviewing your manuscript, and he's reviewer number 2, so we know he's going to be mean. And he says, it's not appropriate to treat your data as continuous. You can't use the Pearson correlation coefficient for data which is not continuous. Your 4-item liquor data, or your 4-option liquor data is not continuous. Please rerun your analysis. Oh no, I'm going to have to go back and somehow ask for correlations between categorical data, and I don't know how to do that. Well, you're using Mplus. You just say that the variables are categorical. It does it all for you. So if I have categorical data, I tell Mplus, these variables are categorical. And it more or less does the rest for you. And so it computes new estimate, or new values for the covariance and the correlation. Now, what Mplus is doing when you tell it that item 1 and item 2 are categorical is it creates a model for an underlying latent continuous variable. And so since it's creating a model, that model doesn't a priori have a metric to it, it's going to be standardized. When Mplus creates a latent variable, they're not always standardized, but in this kind of instance they will be. Unless you somehow specify a metric, it's going to automatically standardize latent variables. So the model results are already standardized because the modeled item 1 and the model item 2 are standardized with standard deviation 1 variables. So the estimate here for the correlation is 0.784, which is significantly higher and kind of in that range of I'm starting to get a little worried about these items here. So my blanket, they're different, I'm okay. I have to make a different argument now. Okay, so it made a big difference from 0.657 all the way up to 0.784. And when I say I made up this example, I don't mean I pulled those numbers out of thin air. I mean I made up some data and ran the analysis on the made up data. So it made a significant difference treating this data as categorical as opposed to continuous. And so now that we have our correctly treated, we told it that the variables are categorical. It's treating those variables correctly. And Freddie Mercury is proud of us. Our manuscript was accepted. What's cool about this example is that I made that correction from I have continuous data to I have categorical data by including a single line. Categorical is this. In other programs, sometimes you can do the same thing, but it would require using a script for being able to deal with categorical data, or using a different procedure, or in some cases, downloading an entirely different package for your program. But here, it's handled natively, and it was a really simple fix inside of Mplus. So, yeah. So the ability to deal with categorical data that simply, all you have to do is tell Mplus which variables are categorical, and everything's taken care of, is a major good feature for Mplus. So, if you're interested in learning how to use Mplus in some of the techniques you're learning about, if you're learning about structural equation modeling, Baron has a book for structural equation modeling with Mplus. If you're very new to Mplus, Geyser's book, Data Analysis with Mplus, is this very gentle introduction that goes a little bit past gentle introduction. So it keeps being useful after I've read through it, I've done, this very basic example, that very basic example. The Mutane's book, those are the authors of Mplus. Regression and mediation analysis with Mplus. Using Mplus is a handful. But if you have a question about regression and mediation, chances are this book is going to help you figure out how to do it in Mplus. And there are others too. More advanced models have books learning this advanced model using Mplus. So there are a lot of resources available. You'll notice that these are all these books are 5 years old or so, or less. And so, as I mentioned, a lot of these major statistical programs have made great advances in the last 5 to 7 years, and so have the textbooks using them have also sprung up. So some more immediately directly useful resources if you're just wanting to say, I'm going to open Mplus, I'm going to do a couple analyses for the first time ever. There's a user's guide, there's a short guide to the language. even if you're a seasoned Mplus user, if you've never looked at the language guide, the very first link there, you need to know that. That is a document on my desktop that I regularly open up. One of the really nice things about Mplus is if you have a question about how to do something in Mplus, why things didn't work quite the way you expected, if you search Google for my question and then put Mplus at the end, chances are pretty high that you'll get links to their forum. And the Mutains and their graduate students have answered thousands, possibly tens of thousands of questions on their forum. And most of the time when I get stuck, I do that and I get unstuck pretty quickly. And compared to trying to troubleshoot issues in other programs, if you're using R, stat.stackexchange, there's a lot of experts in R, but you might have to ask your own question and wait for people to reply and all that. I mean, you might have to ask the Mutains your own question too. But the sort of informal question answering is excellent by the Mutains. So that is the end of my presentation. Thank you all for attending.